The topic for today is an infinite series. Go ahead and do the warm-up. If you start a geometric series and keep it going, dot, dot, dot means it goes forever, and you just keep adding it up forever and ever and ever and ever, what are you going to get when you add up all those numbers? Well, if you want, you can go ahead and try a calculator and see what we're getting closer and closer and closer to. But what I'm describing here is what's called an infinite series. The word infinite is exactly what you think, goes on forever. Goes on forever. And then series is what it meant before, is a sum. So what we're doing is adding up an infinite number of numbers, and that really leads me to that question. Can you really add up an infinite number of numbers? Is that possible? Well, here's a picture that will hopefully illustrate this sum that's going up here. So here I have one square, and the first fraction is 1/2, so let's shade in half the box. So I'll draw a line, and we'll just kind of roughly, I'm not going to do a great job of coloring in. There you go, you got half a box. The next fraction is 1/4, and I don't mean 1/4 of what's left, I mean 1/4 of the total box. So if you cut this in half and start to shade, you got 1/4. 1/8 of the box, well, if this is 1/4, then I should be able to cut it in half and shade 1/8. Cut it in half for a 16th. Cut it in half for a 32th. Then a 64th. And you can keep going and keep that sum going forever and ever and ever. And what is that sum going to get closer and closer and closer to? Well, it's going to get closer to 1. So if that's what you got for the little warm-up, you're exactly right. So can you really add up an infinite number of numbers? Sort of. This is what I'm going to say. Well, obviously, infinity means it goes on forever. So if you're trying to do it by hand, you can't do that. But what you can do is you can take a limit. We're going to take a limit. So we're going to take our sum formula, which was G1, 1 minus, let me rewrite it actually better. We're going to have G1, 1 minus r to the n over 1 minus r. That's how you take a sum of a geometric series. Well, G1, we have a first term, that's easy. A multiplier, I can figure that out. It's multiplying by 1/2 each time to create those terms. But here's what's tricky, is that n is going to be infinity. We'll talk about that in a little bit. Well, if I'm going to add up a series that goes on forever and ever, there has to be one thing that's true about it. Because if I have a series that goes like this, for example, 2 plus 4 plus 8 plus 16 plus 32, it's clear that this sum is getting bigger and bigger and bigger and bigger. So if I added up an infinite number of numbers that behaved like this, well, it's going to, what we call diverge. It's going to go to infinity, and you're not going to be able to add it up. You're going to get infinity. But this one, we could add it up. We added it up and got 1. So what's the difference between this one and this one? Well, one converges and one doesn't. The big question is, how do you know if the series converges? And the way that you know is if your ratio, if your multiplier, is a fraction. If the thing that you multiply by is less than 1, or perhaps a little bit greater than -1. So here's what I mean. -1 is less than r is less than 1. If your ratio is in that range right there, what's going to happen is your numbers are going to continually get smaller, smaller, and smaller. And then your series is going to converge. And when it converges, then you can find an infinite sum. So let's talk about how to do it with the formula. It's actually not a new formula. You have your first term. You have 1 minus r. And then this time n is infinity. An infinite number of terms over 1 minus r. Well, let's simplify that for a little bit, because what's going to happen, I'm going to take this ratio, and we said it's a decimal or a fraction. So I'm just going to pick one that's easy to think about, like 1/2. And what happens if you did 1/2 times itself an infinite number of times? A half times a half times a half. Well, it keeps getting smaller and smaller and smaller, and it eventually gets close to 0. So what's going to happen is when you go r to the 0, and r is a fraction, I'm sorry, if you go r to infinity, I meant to say, and r is a fraction, well, what happens is that this basically becomes 0 because you're doing a fraction times itself so many times. So if this is 0, we can take it right out of the formula, and we'll get our new formula that looks like this. You have G1, and then you'll have 1 on top and 1 minus R. So this would be a formula that can work, but very often what you see is that you multiply these two fractions together, and so this would be G1 over 1 top times top. So the sum is going to be equal to G1 on top, and then 1 minus R on bottom. So you have your first term, 1 minus the ratio, and that's it. So what has to be true in order to find an infinite series? Your series has to converge. All right, so I'll try one. I'm looking at this series, and I want to know, can dot, dot, dot means it goes on forever. Can I find an infinite sum? Well, here's how we're going to do it. First, you have to figure out what your multiplier is. And I noticed that the numerator stays the same, indicating that we're multiplying by 1 on top over and over again. On bottom, I see that the pattern is times 3. So that makes my multiplier 1/3. All right, so once you know the first term in the ratio, you're done. The first term is 5/3. That goes on top. You have 1 minus 1/3 on bottom, and that's it. After that, it's all just keeping it straight on your calculator. So let's give it a try. I'm going to go 5 divided by 3 divided by 1 minus 1/3. Boom. And you got 2.5. Meaning, if you continue to add these numbers up forever and ever and ever, it would equal 2.5 if you did it forever. All right, how about you pause it and try the last two? All right, I can see here now it's getting smaller, but maybe I don't exactly know what my ratio is. Well, anytime if you can't figure out what your ratio is, just pick two terms and divide them. So for example, I could take 160 and divide by 640 I meant to say, and you get 0.25. Well, let's see if that pattern continues. So we'll go 160 times 0.25 makes 40 times 0.25 makes, yep, that makes sense. So that means that my multiplier is going to be equal to 1/4 or 0.25. As soon as you have the first term in the multiplier, you done. On top, we have 640. Underneath, we have 1 minus 1/4, and that's it. So I can go 640 divided by 0.75, and we get 853 1/3. All right, the last one. Ooh, I see fractions here. Let's look at what the pattern is. Ooh, on bottom, I'm seeing that it's the same. But on top, oh, this one actually looks like addition. It looks like I'm going +4, +4, +4. And when you add, your denominators will actually stay the same. So what happens here, this one actually, ratio, it doesn't have one. This one is arithmetic, meaning it has a difference. A difference of, looks like 4/2, or it's adding 2 every single time. Well, this series does not converge. It will increase forever and ever and ever. So if we want to find a sum, we can write DNE, or if you want to use perfect math language, we can say the series diverges. All right, let me know if you have any questions.